In this session, we're going to take a look at the global menu for options in GeoGebra, and specifically we're going down to the drawing pad. The rest of the options menu is covered in a separate tutorial. Under drawing pad, we have a large series of changes you can make to the display of your GeoGebra window. Rather than try to show each of these step by step, which is very time consuming and probably unnecessary, instead we'll go through what each one does and then show an example of how they could be put together. First, we have the background color. It's a simple button which brings up the typical color swatches, and from that we can choose the color we want for the background of the whole drawing pad itself. We then have a group of menu items that can be applied to either the axes or the grid. Right now, under axes, we can choose whether to show the axes or not, and you can see them disappear in the background. We can choose the color, same menu again, but this time we'd be choosing the color for the axes. The line style, we can have a plain line, an arrow at the end of the line, or we can have bold with plain and bold with an arrow. Grid. Under grid we can have the grid show or not show, and this is, you can choose to have the grid show or not show in 2 or 3 different ways within GeoGebra. Again, we can have, if we turn the grid on, we see it appear in the background. We can choose a color for the grid, and when we hit OK, like with all other things, it would appear instantly in the background. Since we're going to wait until the end of this, we'll just turn that right back to a standard white again, and it's gone. Once again, we also, for the grid, let's put that back to standard a moment here. We'll choose black, and we can choose differences in how we want the display to look. Here's a combination of dashes and dots. I would caution you that when you use this combination, in fact some of this combination and a couple of others can get very confusing in their displays depending on what the units are set at. Distance allows you to control the distance in your grid settings. This is now showing pi on the y-axis. Put that back to 1 and close. Let's set this all back to the default settings for a moment so we don't get too confused. Okay, we're back to standard. Going back to the drawing pad again, we had left off looking at the settings for the axes and the grid. Down below that we have another set. It's set for the x-axis alone right now. This allows us to show tick marks on the axis or not, or the axis itself actually. This allows me to show how I'm going to display tick marks, and you can see the small tick marks are showing up between the integer values. The numbers can be displayed or not displayed. The distances can be changed. Right now it's set on 1, but we can set that to pi values as well, as you can see. Or we could even use pi over 2, as you can again see. For example, here's 5 pi over 2. Units, we can use degrees, millimeters, pi, centimeters, meters, kilometers. Quite a choice, or use none at all. Label, if we need to, if it isn't X, we could use alpha or epsilon, beta. There are numerous things to choose from there. There's a whole menu of labels we could put onto the axis itself. The minimum and maximum will simply set the values. You'll notice that this is negative 4.3 on the left hand, and we're up to 8.48, about 8.5 on the right side of the x-axis. The final box here allows us to choose a ratio between the x and y axes if that's desirable, and it might be in certain circumstances, probably involving graphing other than standard work that you'd find in algebra and geometry, but perhaps in graphing related more to statistical graphing. The y-axis has the exact same set of scenarios available as the x-axis. To see how this might be put into use, let's call up an example. Okay, now here we have a graph in which we have set the background to a bright yellow. We have set the axes to a bold, still has the arrows on the end. Our measuring units on the x-axis are in units of pi and broken down by pi over 2, pi, 3 pi over 2, and so on. On the y-axis, we're measuring by ones, by units, 1, 2, 3, 4, 5. This would be a display that would be particularly useful if I were doing something such as a trigonometric function, and let's try that out with y equals the sine of x. In fact, let's even do one better. Let's make it 2 sine of x and see the result. Okay, there is our equation. And now in this case, the scale and the background that we're using is probably much more suitable than the standard would be, because we can immediately see the relationship between the values of the function that we're putting in, that is multiples of pi, and the values of the function output, which is in units, 1 and 2 at the max.